Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at geometric series. Geometric series. Now, in order for us to work with a geometric series, we have to start with a sequence that's geometric, such as 2, 4, 8, 16, 32. And this continues. Now notice all of the terms are multiplying by 2 at each step, so we know it as a common ratio of 2. We know our formula for a geometric sequence is a sub n is a sub 1 times the common ratio r to the n minus 1 power. And we know that if we wanted to write this as a series, all we do is change the commas into pluses. So this is now a geometric series from the geometric sequence that we found using this rule, which would give us 2 times 2 to the n minus 1 power, which is 2 to the nth. That's our rule, and this would therefore be, 2 to the nth, and then continues thereafter. Now, if I wanted to write this in a formula base, I would want to write it into what is called sigma notation. Sigma notation. Sometimes often referred to, notation, let me write that clearly. Often referred to as a series notation. There we go. And we would start at 1 and go up to n. And notice this is 2 to the I, and therefore we would have 2 plus 4 plus 8 plus 16 plus 32 all the way up to n. And this has a formula which will give us our total summation. If we add all of these terms up together, we're going to have a sub 1 times 1 minus r to the nth power divided by 1 minus r. Now you do have to be careful, because when you're using this formula, the n value that you're going to be working with here is found by taking the top minus the bottom and adding 1. Now this is important because this is when we're working with a partial sum, not an infinite sum. If I'm working with an infinite sum, it also has a formula, but it has different requirements. And it's going to infinity now, and it requires that the common ratio in the formula, a sub 1 times r to the n minus 1, requires that the r has an absolute value that is less than 1. Or you're always looking at a value that's between negative 1 and 1. Okay? Now, if that were the case, we would simply have a sub 1 divided by 1 minus r. All right? So two different formulas. Partial sum versus an infinite sum, and an infinite sum only works with specific ratios. Okay? Now, let's take a partial sum for a normal. Let's go back to this problem that we have right here. And we're going to find a partial sum. And we're going to say we're going to find the sum starting from 1 to 8 of 2 to the I power, which would be 2 plus 4 plus 16 plus 32 all the way up to 2 to the 8th power, which is 256. According to the rules and our information that we have, we would then have our first term, 1 minus 2 to the 8th power divided by 1 minus 2, gives us negative 2 times 1 minus 256, which is going to give us negative 2 times negative 255, and that's giving us 610. Now we can check our answer by using a calculator. And if we are working with a calculator, we'll turn it on. We're going to use Math 0. Notice it immediately gives us our information. Make sure you use x as your variable. We're starting at 1 and going to 8. And we have 2 to the power of x. We hit enter, and we get that answer. Oh, and I had one too many. 510. Looks like I added an extra 100 on that. Oh, how silly. All right, let's go ahead and take a look at another partial sum. What happens if our partial sum doesn't start at 1? Well, when a partial sum doesn't start at 1, we have several options, as we've seen in the past. So let's say I'm looking at I starting from 4 and going to 10 for 2 to the I. Well, this is now starting on the 4th term, which we saw was 16, adding 32, then 64, then 128, and we're going all the way up to the 10th. 2 to the 10th is 10,024. Now, according to our rules, we should be able to use a sub 4 times 1 minus 2 to the nth power divided by 1 minus that r again, or 1 minus 2. But we have to be careful because our n now is 10 minus 4 plus 1. That's giving us 7. So we really are looking at 16 times 1 minus 2 to the 7th power divided by 1 minus 2. And if we're doing that, that's giving me 16, and it's a negative now, times negative, what is 2 to the 7th power? Let's just find out what 2 to the 7th power is. 128. That'll be 127. And 16 times 127 turns out to be 2032. Now, if we check our answer, let's just check our answer one more time. We're going to use math 0. Our x is the variable. We're going from 4 up to 10. And we have 2 to the power of x. Ta-da! And we get our answer. Now, when we're talking about an infinite geometric series, please remember that we're now talking about the summation, as I starts from 1 and goes to infinity, of a sub 1 times r, and we'll have I minus 1 here, and this is now the formula a sub 1 divided by 1 minus r. So let's say our first term a sub 1 is 3/5, and our r is 1/3. Putting this into our formula, 3/5 times 1/3 to the I minus 1 power, I minus 1. We have our summation, I starting at 1 to infinity. I'm just kind of setting things up. This now has to be our first term. And now be careful. Let's make sure we have our r here. There we go. So I have my first term, 3/5 divided by 1 minus 1/3. This is going to give me 3/5 divided by 2/3, and that's 3/5 times, 3/2. And this is going to give me 9/10. So my infinite sum would be 9/10. Now, keep in mind that this works for the problems that we've already done. Let's say that we have our first term is 1/2, and our common ratio is 1/2. Oh, let's put it I, please, Mr. Lamb. So we're going to go I, summation, I goes from 1 to infinity. Well, this is our first term, 1 minus 1/2. That's going to give me 1/2 divided by 1/2, which means that this sum is 1. Okay? So the infinite geometric series are not difficult as long as you follow your rules, and neither are geometric series. All right? I hope this has helped. Please remember, if you find this to be a helpful video, please remember to click like. If, however, you have constructive criticism, please feel free to let me know. I'm always interested in improving my videos. Thank you very much, Hornets. Please be well, be safe, and take care. Thank you very much. Cheers.